are looking at a live view of the Falcon Heavy. Yes, the Falcon Heavy on historic pad 39A at Kennedy Space Center, awaiting liftoff at 3:45 p.m. local time. Welcome to our live launch webcast. My name is Lauren Lyons. I'm an engineer in our flight reliability department here at SpaceX, and I am so excited to be here with you today, along with my co-hosts, bringing you coverage of the first ever test flight of Falcon Heavy. At liftoff, Falcon Heavy is going to be the world's most powerful operational rocket by a factor of 2. And today is the day that we attempt to demonstrate that power. And because it is a test flight, there is no satellite customer on board the vehicle today, but the fairing is not empty. We do have some very interesting payloads going up on this flight that we'll talk about later on in the webcast. We'll also walk you through the mission profile because this ain't your typical Falcon launch. We've got 28 engines, 3 boosters, 3 separation events, 3 landing attempts, and there's going to be a lot of activity happening all at once. So this test flight is bound to be exciting one way or another. All right, we've got a ton to walk you through today, so let's get going.
Hi, I'm Michael Hammersley, a materials engineer in avionics department. We're very excited. I'm sure you can hear it. To my right, we have a live view of Falcon Heavy on the pad at Kennedy Space Center. Falcon Heavy is essentially 3 Falcon 9 rockets all strapped together, which means it can carry much larger payloads not only to Earth orbit, but to the Moon and Mars as well. So like Falcon 9, Falcon Heavy is a 2-stage launch vehicle. The big difference is that the first stage in Falcon Heavy is comprised of 3 cores, while Falcon 9 has only 1. Now, each one of these 3 cores has 9 M1D engines, making for a total of 27 engines overall. Altogether, those engines produce 5 million pounds of thrust, which is equal to 18 747s at takeoff. In fact, the engines are producing so much power that we don't run them at full thrust all at once. So during ascent, Falcon Heavy will throttle its thrust up and down in both the side and the center cores in order to balance the aerodynamic and structural loads on the vehicle. So about halfway through the first stage's burn, the 2 side boosters will separate and come back to Earth for a simultaneous landing at Cape Canaveral Air Force Station. More about that a bit later. Wait. At that point, the mission proceeds very much like a standard Falcon 9 flight. The center core will keep on firing for another minute to burn all of its fuel, and it will perform a standard stage separation from the second stage on top. This second stage, with the fairing right at the very top there, the second stage is exactly the same as any other Falcon 9 flight, except we've loaded a bit more helium onto it this time. Now, that second stage will be sending our payload way out into a Mars-crossing orbit, which we'll also get into a bit later. But all in all, with a successful launch, Falcon Heavy is going to be the largest and most powerful operational rocket in the world. We're very excited to be launching it today. Let's check in on exactly how it's doing.
Good afternoon. I'm John Innsbrucker, the Falcon Principal Integration Engineer at SpaceX. We're currently at T-minus 17 minutes, 40 seconds and counting down. The good news that all systems are go for launch. We're working no problems with the SpaceX test flight of the Falcon Heavy launch vehicle. Now we're currently loading propellant on all 3 first stage boosters, and we began loading a couple minutes ago on the second stage LOX tank. Now this is the same method that we use on the single-core Falcon 9. It just scaled to handle 3 first-stage boosters. Now we're loading liquid oxygen and kerosene. We do that because in order to support combustion, you need oxygen. And in the vacuum of outer space, there isn't any. So we bring our own liquid oxygen, chilled and densified. You may have heard densified in the past. That allows us to pack the maximum amount into the LOX tanks on the Falcon Heavy. Now our fuel is refined petroleum, RP1. That's essentially just a purified kerosene. It's a safe propellant, easily available, has a lot of history. For example, the Saturn V first stage, flown from the very pad you see on the monitor, on the moon missions, used kerosene and liquid oxygen. Now the big news this afternoon has been the weather, and we've eaten up most of our launch window. Now, we won't have the ability to hold the countdown any further now that we are into liquid oxygen loading. The good news is that the winds are looking good. We're working no issues on the Falcon Heavy. However, if there is an issue in the last minutes, we won't be able to launch today. There is a backup date available tomorrow. And I've said it before, launch is hard, and Falcon Heavy is no exception. We're essentially counting down 3 rockets simultaneously. So the SpaceX team is going to be conservative in case anything pops up in the last minutes. But as the energy and the enthusiasm from the team gathering below me outside of Mission Control Center X is growing, we are go at T-minus 15 minutes and 40 seconds and counting.
My name is Brian, and I'm part of the software team here. And I'm standing just outside Mission Control as the crowd gathers behind me. We're all anxiously awaiting this very first test flight of Falcon Heavy. Now, today, SpaceX has over 6,000 employees in locations across the country. But it wasn't always like that. Now, when SpaceX was first founded in 2002, it was just a small group of engineers who believed that they could reduce the cost of exploring space, but had never actually built a rocket themselves. Now, Falcon 1 was the first rocket we developed, and it was pretty small relative to Falcon 9 and Falcon Heavy. While the Falcon Heavy on the right of your screen is over 230 feet tall, Falcon 1 stood only about 70 feet tall and could only carry about a half a ton to orbit. However, despite its small size, Falcon 1 served a very large purpose. It was our roadmap to using modern technologies to engineer a vehicle that was not just more reliable, but was less expensive than alternatives. Now, we had 3 test flights of the Falcon 1 before we found success. But on that 4th Falcon 1 flight, it became the first privately developed liquid-fueled rocket to reach Earth orbit. Now, fast forward to today, and SpaceX has had 49 successful rocket launches. We have recovered 21 first stages, and we have reflown 6 of those. We have had 14 Dragon launches and have successfully reused the spacecraft as well. Now, our next step on this journey is just minutes from now when we'll attempt the first test flight of our heavy lift launch vehicle. Now, there have been many challenges along this long road, and it has not been easy. But no matter what happens today, it has all been worth it. Now, one of the many challenges we're hoping to overcome with this test flight is the recovery of all 3 cores of the Falcon Heavy first stage. Although we have demonstrated success with the recovery of a single core, 3 is on a whole nother level. So let's check in with Michael to get an overview of what that story may look like.
At SpaceX, our primary goal is to enable people to live on other planets, most notably Mars. But it's hard to do this without dramatically lowering the cost of access to space. And the best way to accomplish that is to reuse as much of the rocket as possible. So we've been successful at landing and reusing Falcon 9 rockets for over 2 years now. And Falcon Heavy aims to continue this trend of reusability. So today, we'll be attempting to recover all 3 of the first stage cores by using both of our landing methods, by land and by sea. So the side boosters have actually been used before on missions TICOM 8 and CRS 9. And at the time of booster separation, during ascent, the side cores will still be going slowly enough to turn around. So it makes sense to return them to Cape. They'll be executing a 3-burn maneuver to get them back to landing zones 1 and 2 and Cape Canaveral Air Force Station. You may have heard of landing zone 1. Landing zone 2 is an identical landing pad right next to it for Falcon Heavy landings. The center core will be going too fast to efficiently return it to Cape Canaveral Air Force Station. So we're going to use the autonomous spaceport drone ship to catch it about 300 miles off the Florida coast. It will also be executing 3 burns to get there. So if all goes well after launch, we'll have 3 first stage cores back on Earth, 2 for the second time, and a wealth of data for perfecting airplane-like operation in the future. So countdown is still proceeding nominally. So let's check in again on how Falcon Heavy is doing.
We just passed T-minus 12 minutes in the countdown of the test flight of Falcon Heavy. Fuel is completely loaded on the second stage. The first stage is also loaded with fuel, except for a small top-off that'll happen between T-minus 7 minutes and T-minus 6 minutes. Our major activity now is loading liquid oxygen on the boosters and the second stage. Liquid oxygen propellant loading on the first stages will end between T-minus 4 minutes and T-minus 3 minutes. Liquid oxygen loading on the second stage is the last one to finish, ending by T-minus 2 minutes. Now, in addition to loading propellant, the team is preparing to perform their final checks of the Merlin engines. will begin chill-in of the Merlin engine turbopumps with liquid oxygen as typical at T-minus 7 minutes like we do on Falcon 9 flights. We'll also be verifying valves and using the thrust vector control actuators to move the engines to verify the actuators are working correctly. As we get to T-minus 4 minutes, the clamp on the top of the strung back will open. You can see it just behind the Falcon Heavy. That entire structure will move about 1.5 degrees away from the rocket. At liftoff, it will move the rest of the way to clear Falcon Heavy, just like Falcon 9 flights. At the T-minus 1 minute mark, the flight computers will go into startup mode. They'll be controlling the countdown on the Falcon Heavy. What's different in this flight, engine ignition will begin at T-minus 5 seconds on the 2 side boosters, followed 2 seconds later by the center core. Now we're continuing to watch the weather, making sure that the ground liftoff winds don't exceed the maximum, but they're looking good right now. We continue monitoring the upper altitude winds as reported by the balloons. But right now, at T-minus 10 minutes and 10 seconds and counting, the Falcon Heavy test flight is go.
Because the first flight of Falcon Heavy is a test mission, we do not have a customer spacecraft on board today. Instead, we put something a little special with SpaceX inside the fairing. Now, more often than not, on the first flight of a new rocket, engineers will choose to fly a mass simulator, which is basically a heavy object of some sort to simulate the dynamics of flying a payload, but with little consequence if the mission doesn't work out exactly as planned. And as many of you already know, we have opted to have a little fun with our mass simulator. Stacked inside the fairing is Elon's cherry red Tesla Roadster, and inside of it, a passenger. His name is Starman, but don't worry, he's not human. But he is donning the SpaceX-designed spacesuit that our human astronauts will be wearing on Crew Dragon. And if all goes well today, we hope to get some live views of it as it makes its way into space. Now, in addition to the Roadster, you might also catch a glimpse of a smaller passenger, which is a tiny little Hot Wheel Roadster carrying a tiny little Starman, which is a little Easter egg for today's mission, so keep your eyes peeled for that. But those are not the only payloads we're flying today. Secured inside the Roadster is another really special passenger called an ARC. An ARC is a 5D laser optical quartz storage device, which is essentially a high-tech, high-data storage unit that can survive in the harsh environment of space. It's built by the ARC Mission Foundation, which is an organization whose purpose is to store libraries of human knowledge and data on these devices and send them off into space with interplanetary travelers, thus preserving human achievements well beyond Earth. On the ARC that's being launched today, the Foundation has stored Isaac Asimov's classic sci-fi series, The Foundation Trilogy, which was the original inspiration for the ARC mission. And given that making humanity a multiplanetary species is the core purpose of SpaceX, launching an ARC on this mission just seemed fitting. And last but certainly not least, a little something special for our hardworking SpaceX team. Mounted on the payload attach fitting, which is the structure that holds the Roadster onto the second stage, there's a plaque on which the names of over 6,000 of our SpaceX employees are engraved. The work that goes into designing, building, testing, and launching a vehicle of this sort is no small feat. And we are super excited to be a part of the Roadster's billion-year journey through the solar system.
As Lauren just mentioned, if all goes well today, Falcon Heavy will put the Roadster on board into an Earth-Mars orbit around the sun on a journey that could last for 1 billion years. Now, on a universal scale, this means that the Roadster will be tracing the shape of an ellipse with the sun at one of its fixed points, or one of its foci. Now, we call this heliocentric because it is sun-centered. The outermost distance on that same ellipse will intersect the path that Mars takes while it is on its own journey around the sun. That's quite far away. That will reach a maximum distance from Earth of over 400 million kilometers. In Earth terms, that's about the same as a trip around the equator 10,000 times. Now, during its journey, the Roadster will also reach a maximum velocity of nearly 40,000 kilometers per hour, or about 20 times faster than a speeding bullet. Now, as we said, it should stay up in orbit around the sun for about 1 billion years, and it's a very long, exciting road ahead, and we are thrilled to be able to take the first steps on that journey just 5 minutes from now.
The SpaceX team continues to count down for launch of Falcon Heavy test flight. Now, once we light the engines, Falcon Heavy will check the power on all 27 Merlin engines, a critical period in the go-no-go for launch. It'll then command release from the ground hold downs. 40 seconds into flight, we'll decrease power on the two side boosters in preparation for maximum aerodynamic loads on the vehicle. Once we get through this period, Falcon Heavy will throttle back up to full power on the side boosters. About half a minute later, we will again throttle down the two side boosters. This time we're decreasing the forces on the rocket structure. At this point in flight, the vehicle is much lighter, having burned off much of the propellant, but we are increasing thrust. 2.5 minutes into flight, we'll fully turn off the side boosters, an event called BECO, Booster Engine Cutoff. At this point, the pneumatic separation system on the center core will unlock the two side boosters and push them away. The side boosters will disconnect first at the top of the center core, then milliseconds later from the bottom, so they'll actually rotate away from the center core slightly. Once the side boosters are clear, the center core will throttle up to full power and burn for another 25 seconds. Finally, at just past 3 minutes after liftoff, the center core will shut down, an event called MECO, Main Engine Cutoff, and the second stage will separate. From this point on, it's like a Falcon 9 mission. The fairing will separate, the MVAC-D upper stage engine fires, eventually sending the stage and payload out into the solar system to orbit around the sun. So that gives you a feel for the sequence of events we're planning on today's flight. So now, at T-minus 4 minutes 45 seconds and counting, let's witness the test flight of Falcon Heavy.
MVAC and A1D fuel bleed has started.
Safety
NY locks low, throttling to close out. NY lock slide complete. PY lock slide, throttling to close out. PY lock slide complete.
Stage 2 TVC motions nominal.
BOGO bleed verification. Center core lock slide complete.
Strombeck lower has ended. Strombeck's at 88.2 degrees.
Stage 2 lock slide complete. Falcon Heavy prop load is complete. Falcon Heavy is on internal power. Vehicles in self-align.
Ground gas close has started.
Falcon Heavy gas loads are complete. M1D fuel bleed complete. M1D engine chill is complete.
AFTS is ready for launch.
Ground gas closeouts are complete.
Falcon Heavy is in startup. Stage 2 present for flight.
T-minus 30 seconds.
Launch director on countdown 1. SpaceX, Falcon Heavy, go for launch.
Falcon Heavy is configured for flight.
T-minus 15, standby for terminal count. 10, 9, 8,
Side booster ignition.
6, 5, 4, 3, 2, 1, 0. Ignition.
Seconds, if you can hear me over the cheering. Falcon Heavy heading to space on our test flight. Building on the history of Saturn V Apollo, returning pad 39A to interplanetary mission. We're getting ready to throttle down for max Q. You've heard the call out. Vehicle is supersonic. Side boosters are now throttling back up to full power.
Vehicle has reached maximum dynamic pressure.
We're past max Q, the period of maximum loads on the vehicle. Next up, we'll be waiting for the side boosters to begin to throttle down prior to booster engine cutoff and separation 2.5 minutes into flight. GNC trajectory looks good on the Falcon Heavy. Reports show that the M1D engine performance is nominal.
Conduct engine chills begun.
Side boosters have begun to throttle down in preparation for the upcoming shutdown in 20 seconds. Major event coming up with side booster shutdown and separation.
Inside shutdown. Side boosters. Beacon. Center. We're throttling up. S1 keeps going. Still booster base box started.
Successful separation. We're coming up on MECO and shutdown.
Stay set.
Separation confirmed.
Event recognition. This big burn looks good on side boosters. Spectrum startup.
Coming up on fairing separation.
Center core side engines on power, also look good. Side booster, boost back, shutdown.
Center core boost back burn shutdown.
Acquisition of signal.
Wow. Wow. Did you guys see that? That was awesome. That's the only thing I can really
that was
say right now.
absolutely wild. Absolutely wild. I got nothing else.
Oh, man. Recapping all the great things that you just saw there. Successful liftoff from the pad, successful stage separation. But before that, successful booster separation. You can see stage one. The two side boosters, pardon me, you can see the center core, and you can see MVAC lit up. Oh my gosh.
Then the beautiful shots of Starman chilling in the Tesla Roadster. Just absolutely incredible. On your screen at the moment, you've got a few things happening. On the upper right, you've got MVAC D continuing its burn. On the upper left, you have the center core headed back towards the autonomous spaceport drone ship. And in the two bottom screens, you've got the side boosters headed back towards Cape Canaveral Air Force Station, landing zones 1 and 2. The next step coming up for the side boosters and the center booster is the re-entry burn. That's going to slow it down from, or slow all the boosters down from way faster than the speed of sound to just faster than the speed of sound in order to reduce some of those aerodynamic forces and heating that occurs when you're moving that quickly through the atmosphere.
And as you can see on your screen, that re-entry burn for those two side boosters has begun.
Side boosters, entry burn, shut down.
Side core entry burn target.
The center core in the upper left of your screen performing its own re-entry burn. You can see the edge of Cape Canaveral in both of the side booster cameras as those are coming in.
Some PY and NY side boosters have saved.
Center core entry burn shutdown.
And even though those look very similar, those two boosters views, those are actually representing different boosters. And they're heading towards Earth. They're about to begin their landing burns. We'll hopefully be able to bring you nice footage of that.
Both side boosters transonic.
And watch for the landing lights deploy at the tail end of that landing burn.
And that landing burn has started.
Both boosters looking to be on track towards their respective landing zones.
Landing burns have started. Side boosters landing legs are deployed.
And the Falcons have landed.
LZ1, LZ2, both side boosters have touchdown. Landing operators move on to one by one. Recovery 1 and recovery 2.
And coming up very shortly, the center core will be attempting its landing on the autonomous spaceport drone ship.
Check on your screen. Sometimes this footage goes out when it approaches the drone ship and the heavy vibrations make it lose signal. We're crossing our fingers that's not the case right now.
Stage 2, nominal parking orbit insertion.
So it looks like that landing is happening at the moment. We have lost signal. We're hoping that signal comes back shortly.
Oh, man. Yeah, as Michael mentioned earlier with the vibrations of the rocket and how it shakes up the cameras that are on the drone ship, sometimes we do lose signal or shakes up the antennas.
Oh, and we've just gotten confirmation.
Oh. We're waiting to hear what happens, and so we're listening in, and we're still waiting to hear. We'll let you know as soon as we find out. You'll know. People are cheering, but we'll get the call and know hopefully very, very soon how that center core is doing, whether it's standing up proud on that drone ship or not.
Meanwhile,
other two landings.
those were absolutely gorgeous. Meanwhile, the second stage is continuing its trajectory towards Mars. It's all looking good there. John Ike, come give us a recap of the full mission.
He stands.
Well, if you could hear all that cheering, it was an outstanding test flight of the Falcon Heavy. Cameras cycling right now. Live views coming down from low Earth orbit. The second stage successfully got there, and it got there as the culmination of a great Falcon Heavy test flight. We lit 27 engines, throttled the boosters up and down. We separated the side boosters. They came back spectacular, simultaneous landing. The center core did its job. The second stage did it. Everything that you could want in a test flight, we got here. Now we're just looking for the icing on the cake to find out what happened on the drone show. But all in all, an outstanding test flight for Falcon Heavy.
Wow, what an absolutely momentous occasion. Thank you so much to the range for contributing their expertise to today's launch, the FAA for the licenses to launch and land those boosters, as well as the rest of Falcon Heavy. And thank you to you, the viewers, for joining us for a really, really cool moment here.
And to find out what happened with the center core and what's going on with Starman as he makes its journey through space and all of our other launches, you can visit us at SpaceX.com and follow us on social media on LinkedIn and Twitter.
If you would like to join us on exciting projects like these, please visit SpaceX.com/careers. From the entire grateful team here, thank you again for joining us. We'll see you next time.
Take a look at the old man beating up the wrong guy. Oh man, wonder if he'll ever know. He's in the best-selling show. Is there life on